All right, we're going to go ahead and get started here today. The goal of today is to talk a little bit about the project on energy laws, which is in Unit 4. And this project really deals with the laws of thermodynamics, and that goes along with the lesson, or the first part of the lesson that you worked on in the unit. So I just wanted to take some time, go over the objectives, give you a little bit of introductory information, and then give you some ideas about what I'd be looking for in the project. So hopefully, um, your lesson gives you an idea of how to distinguish between potential and kinetic energy. Um, Understand that we all require and use energy at every point in our life processes. Can you identify the first and second laws of thermodynamics, and then as an end result of that, being able to define um, energy loss to chaos and disorder, which is entropy? Okay, so let's take a moment here and talk a little bit about those laws of thermodynamics. Okay, your lesson specifically discussed one of the characteristics of living things, remember, is metabolism. Okay, it's that ability for your body to obtain energy that's necessary to sustain those life processes: digestion, respiration, um, excretion, all of those things that we discussed back in the beginning of the year. So with that, um, your body has feelings because it's constantly working to keep you alive and help you growing. Okay, so when we talk about energy, okay, we refer to energy as that ability to do work. Okay, and work always uses energy. So growing, your cell on a cellular level, just staying alive requires an input of energy, that the ATP. Okay, so does moving. Okay, and energy can be stored as potential energy. Okay, in your cells and in your body, or it can be used kinetically, the energy of motion. All right, so with that, we need to talk a little bit about thermodynamics. Okay, so think about this. If you've been running around all day doing, whatever you were doing, if you're at a school playing a sport, or, if you're getting off the school bus, or, even getting up and moving around the house to get to the computer to do your work, you have to energize yourself. So that might require a little bit of rest, but it also requires you to input your energy through food. Okay, so we know that we can't create our own energy, so therefore it has to come from somewhere, and that's where the first law of thermodynamics comes into place, as such that it's called the law of conservation of energy. And what that says is that energy can't be created or destroyed, but it can change form. Okay, so with the first law, essentially, an organism can absorb its energy from the environment, or it can give it up to its surroundings, in the form of heat loss, for example. All right, um, but once an organism captures its energy, that energy is typically used for its own gain, for its own biological work. Okay, so think of the process of photosynthesis, whereby green plants actually make food. All right, that would be an example of taking energy from sunlight and then converting it into a food source so that the plant has a usable form of energy. So that would be an example of the first law of thermodynamics at work. The second law, okay, think of when a heterotroph, an organism that can't make its own food, um, eats a plant. So let's talk about a first level consumer. Okay, when let's say a caterpillar eats a plant, what happens to that energy? Well, the caterpillar transforms that energy from food into chemical energy, initially in the form of ATP, and then after that into mechanical energy, which helps the organism move around. Okay, now not all that energy taken is useful for work. Okay, and this is where the second law of thermodynamics comes in that energy transformations occur. Some of that energy escapes as heat to the environment. So not all of the energy that you take in as an input, or any organism that takes in as an input, is 100% efficient. Okay? Um, so when you're talking about energy transformations, we talk a lot about heat loss. Okay, heat's not a usable form of energy for many organisms, so when it's gone, it disperses to the surrounding environment. Okay, so the second law of thermodynamics essentially is when a process converts energy from one form to another, some energy converts itself into heat, which is an unusable form of energy that just dissipates into the environment. It's not lost, it just changes form and it moves to a different portion of the biosphere. Okay, so that goes along with that. Remember that no chemical process or biological process is 100% efficient. Um, there's always a loss of energy, a loss of heat in many cases, um, to the system. So those really are the guiding principles behind the thermodynamics. And let's take a few minutes here and talk a little bit about the project now. Okay, so here's your project. And the project says that energy comes in many forms: thermal, nuclear, chemical, mechanical. We talked a lot about thermal and chemical just a few moments ago, but there's tons of other energy out there. So even though there are many forms of energy, all energy that's out there abides by the same rules or laws. Okay, so for this project, your goal is to write about the first two laws of thermodynamics. Okay, and then define the laws and provide an example to help explain it. All right. So just a few minutes ago, I gave two really good examples of each law in action. So, what I'm looking for in this project is for you, in your own words, to explain the first and the second law of thermodynamics. And then in the next paragraph, or even using bullet points, give me an example of the first law of thermodynamics in action in everyday life. And then in this, and the same thing for the second law. Give me an everyday example of the second law of thermodynamics in everyday life and how they would be applicable to you or to another organism on the planet. Okay. I'm not going to hold you to 175 words. I'm just going to hold you to can you explain the two laws, and can you give me two solid concrete examples that show me that you understand the application of each law in the context of the assignment. Okay? So, with that, that's the assignment. Very short, very simple. If you have any questions or you have any problems, please seek me out in the virtual office, and I'll be more than happy to further assist you. We'll be back here next week talking about another project, and I hope you all have a great week. Happy holiday, and we'll be back here next Monday at 3.